So if you take a principal, you push it forward in time, and you pass a compounding event with an interest rate R, then you pick up a factor of 1 plus R, okay? And that's it. If you understand this concept, you are golden, right? You pass through a compounding event, interest rate R, you pick up a factor of 1 plus R. Everything that we're going to do over the next 3 weeks is a direct application of this idea, okay, of this concept. So it's absolutely critical that you understand that and that you be very, very comfortable with this right now, okay? And, you know, hopefully you are. And if you're not, that's fine, right? We've got, you know, a couple of days before our Tuesday lecture, and you should ask as many questions as you can in Piazza or drop into tutorials or whatever the case might be. But this has got to be something that you're very okay with, okay? Pushing a principal through an interest rate R picks up a factor of 1 plus R, always. Does this involve sigma notation? Absolutely it does. That's why we gave it to, you know, in the first part of this week. So yeah, it's going to be sigma notation and lots of it. Okay, so let's get started on some questions. Yes, I know it's being recorded. I am the one recording. Oh, shoot. You know what? I only shared, hold on, give me a second. I want to share the entire screen. Yes, there we go. All right, so we're going to start off with this question. I am going to pop the polls up so that you can all vote. Okay, and I want you to take a second and I want you to read that and tell me what you think it is. I really love this question because I think a lot of students get really stuck on this one. Okay, so I'm going to share these results. This is close enough. I'm actually not going to take up the answer, but instead what I'm going to do is I'm going to give you a little bit of a hint, and then I'm going to ask you to try this again. Okay, so right now we seem split on A, B. Some people think D. So I'm going to tell you, first of all, the correct answer is not D. We know for sure what the answer is. Okay, so the answer is either A, B, or C. And what I think you should do is figure out, let's see, how can I give you a hint without, you know, giving something away? The hint is do the math, right? The hint is legitimately, you could maybe do trial and error. I don't think that like that's a terrible, you know, way of doing it, but like legitimately do the math. How much money do they have after 2 years, right? Just write out the formulas for this. If you understand the simple compounding interest, you'll be able to actually compute how much money each of them has at the end of 2 years, okay? So I'm gonna open up the polls here again. And I don't want you to guess, okay? I don't want you to stare at this equation and guess. I want you to legitimately write it down and try and figure out. I am extremely worried because already we're splitting 50-50. Aziz, can you see the poll things?
I'm not a host, so I
Right.
can see the option, but I don't see the answers being put in. You have to make me a co-host, I think, and then I'll be able to see it. Ah, I see here. We're good now. It's very split right now.
Mm-hmm. Can you write them as a fraction and cancel out terms? Depends on what you mean by that. Wow. This is something.
It's actually very intriguing how close this is.
Yeah, it's crazy how close this is. It's not looking good. Isn't the answer in the question? Maybe, it depends. You know, there's very much a sense. Okay, I'm going to close it in about 30 seconds. There's very much a sense in which I love questions where the class is split, because it really says that there's an opportunity for us to discuss something that is going to be beneficial to a lot of people, right? To really shed some insight on what the correct answer is. So I actually get quite excited for these questions where the class has no idea, or a split between two answers. 10 seconds.
I think 2 believes the answer is option E, but I might have to disagree on that one.
All right, let's look at this result. Oh wow, that's pretty great. I am so proud of you all that somehow you managed to get that to as close to 50%, like an even split between A and B as you possibly could have done. Okay, so let's let this one be. Okay, let's find out. Let's find out what the correct answer is, because, you know, a solid half the class thinks that it's A and a solid half the class thinks that it's B. And again, what I want to encourage you here is that in these sorts of questions, do not guess, don't use your intuition, do the math and trust the math. Okay, so this is question 8. So who has what? Actually, you know what? It occurs to me that I've forgotten who has what. So what did Srishti have 2N? Does anyone remember?
Yes.
Yes, okay. Srishti has $2N. Okay, and Paula has N. Yes, I'm still recording. Okay, has N dollars. Okay, compounds monthly. Did I give a rate? Did I call it R? Yes. Okay, perfect. Well, some people say no, some people say yes, but whatever. We compound monthly at a rate R. Okay. And so even if you don't know the rate, we're just going to make one up. We're going to give it a name. We're going to call it R. And we're going to do this for 2 years. Okay. Somebody tell me how many compounding periods have passed?
12.
Okay. After
24.
24, right? 2 years. So how many compounding periods? The answer is 24, right? And the reason for that, there's 24 months in 2 years. And we compound every month. Okay, so how much money does Srishti have? Srishti. Why is my stupid thing doing that? Why is my pen not working? All right, give me a second. Technical difficulties. Good, 24. R is constant, so it's negligible. Steve, can you elaborate on that? Well, Shanzai, nobody knows. Well, okay, so Faizan, you know, you're right. We could actually give them amounts of money and do that as a trial and error thing. I actually, though, I kind of want to leave it abstract, but you could do it that way. That's 100% okay. Yeah, sure, turn on your mic.
What I meant is that, so let's see, P Paula over P Srishti or whatever his name is,
Okay,
is equal to N multiplied by the rate to the power of 24 over 2N multiplied by the rate to the power of 24. And because R is a constant, you just cross them out. And you just cross out N and N, and you just cross multiply.
And so you get what?
You get 2.
Okay, sure. Okay, so
2
you're
of what? So basically,
yeah.
Sri. Oh God, Jesus name.
S
so
is
basically,
name.
yeah, S. So basically, S just makes double of what Paula just made.
Right, sure. Yeah, okay. So you've divided them, and that's absolutely correct, and we can do it that way. I'm going to do it a slightly different way, but I'll show everyone kind of what you're saying, but absolutely you're right. Okay, so someone tell me, how much money does S have? right? And Saif just kind of like said it, but how much money does S have? You know, can you put it in the chat? Just do your best to write it out because I know there's like an exponent in there. Anyone? Okay, Namir, close. Be careful. Gregory, yes. Okay, great. Emma, be careful, right? Srishti had two N dollars, right? Not N dollars, but otherwise you'd be right. Right? Everyone's okay with that? Yeah, no problem. I assume it's just a small typo. So remember what I said, right? When our principal passes through a compounding event, it picks up this 1 plus r. We have 24 compounding events. We're going to pick up 1 plus r to the power of 24, and we multiply that by our initial principal. That's 2n. How much is Paula's? And then, you know, if we were in person, I would be elbowing Emma. Yeah, exactly. There we go. Okay. And what's the difference between these two? So Saif's, you know, what Saif was saying was that if you divide S by P, basically everything cancels out, right? And you're actually computing the ratio of them. But yeah, S is just exactly 2P, right? I.e., Srishti made exactly twice as much as Paula did, right? Yeah, exactly double. So the correct answer is, what was it? It was double. So that was A, I think. Yeah, so it was A. Does that make sense? Does everyone see it? This is a great one because a lot of people, if you actually ask, you know, the average person on the street, a lot of them will tell you B as well, because their intuition is that, well, because Srishti has more money, she's making more interest, right? And she absolutely is, but the amount of interest she's making is exactly twice as much as Paula is making, right? So yes, she has more money. Yes, she's making more interest, but it's the amount of interest she's making is directly proportional to the amount of money that she started with, okay? No, it's okay. So this is what I mean by trust the mathematics, right? Don't trust your instinct on that. Sometimes your instinct is wrong. You got to trust the math. All right. Are there any questions about this? And everyone, again, it's okay to be wrong here. I don't want you to, okay, I don't want you to feel dumb. I don't want you to feel stupid. This is how you learn, right? There's never a time that you're going to learn better than when you make a mistake, right? So you've all made this, you know, for those of you, half of you made this mistake now. I promise you, you will never make this mistake again, right? It will never, ever happen again, precisely because you've made this mistake now. And you know, you're like, oh, damn, that's not how it worked, right? So just kind of keep that in mind. This is a great opportunity to learn from your mistakes. And in fact, you know, if you don't tell anyone that you made a mistake, no one will know. Like, I can't even see how you all voted. I mean, I could, but it would be a lot of work, and I don't care nearly that much. Okay. How is it S is equal to 2P? So if you look at these two things, they're exactly the same, right? The only difference is that if I were to multiply P by 2, I would get S, right? So if you just look at them, if I put a 2 in front of the P, then I would get the exact same thing as I have in S, right? Okay, let's try this one. Okay, and for the record, everyone, you will need a calculator for this question. So if you want to use one, that's totally okay. Pull up like Wolfram Alpha or something. and 2, 1. That's okay. It's all right. And again, Jack, like if you get it, if you know you got the right answer and you just made a small mistake in the calculation, like who cares? Because you know you got the right answer, right? Yeah, everything compounds monthly. Okay, so B seems to be the predominant answer. It's and B is correct. Okay, so B absolutely is the correct answer. And the way that we're going to have to solve this is we're just going to have to sort out what the value of the accounts are, and then we're going to have to plug them into a calculator. I'm going to have to see which account has more. And the accounts are actually really close. I think, you know, when I did the math, they're off by like 73 cents. So it is pretty close. And so, you know, if you made a silly rounding error, you definitely might have gotten the wrong answer. But again, if you get, I'll show you at what point, if you get to, you should be happy, even if you screwed it up. All right, so here's question 9. All right, so account A. So account A does the following. So we do 1% for 6 months. And then we do 3% for 6 months. Okay, now some of them you definitely need a calculator. What are you gonna do? Some of you, can you write out for me in the chat what you think the value of the account is after 1 year, after 12 months? Okay, yeah. So for those of you saying 12, 67, 51, you're absolutely correct, but can you give it to me not like evaluated? So what is it? Yes, perfect. Thank you, Edward. That's what I was looking for. But like everyone else, if you got 12, 67, 51, you clearly also got that as well, but perfect. So it's 1,000, 1 plus 0.01 to the power of 6, 1 plus 0.03 to the power of 6. Now, are there any questions about that? Is everyone okay, like where that number came from, right? And you can work it out. You can like plug that into a calculator. And what is it, 12, 67, 51? Okay, does anyone have any questions about where that came from? Because now is a critical time to ask if you're not comfortable with that.
I think there's a raised hand.
Is there a raised hand?
Yeah.
Okay, yeah, so whoever raised your hand, are you just signaling that you're kind of stuck? What do you mean add them separately? I'm not certain. You could just put 1.01. We know that that's true. It's kind of nice to separate the 1 and the R, Michael, but like, yeah, I mean, clearly they evaluate to 1.01. So that would be totally okay, right? Maybe let me just show this one really, really quickly, because this is kind of a nice point. And I think this is the best way to do this is, again, with a timeline. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Okay. And we have 1%, 1%, 1%, 1%, 1%, 1%, 1, 2, 3, 4, 5, 6, right? 3, 3, 3, 4, 5, 6. And so when we start with a principle here, every time we push it through one of these events, oh, no, yeah. So you don't want to add, like it has to be like, where's the 1061.50 come from? I'm not certain. And Rafid, I don't know quite what you're writing, but so, okay. So like if I push this through the first compounding event, right, it becomes 1 plus 0.01 after the next event, and so on and so forth until we get to after the 6th compounding event. And then I start picking up these times 0.03s, right? And by the time I get to the end, I've passed through 6 compounding events at 1% and 6 compounding events at 3%. And so that's how I managed to pick all of those things up. Wouldn't P be added? No. So this is actually an interesting idea. Like, would P be added after each compounding event? I didn't reinvest $1,000 at the end of every month, right? That's what that would be. So Agam, you're actually like looking forward to something else, which is called an annuity. But in this case, I invested the money say January 1st, and then didn't touch it, right? Just let it sit there and continue to collect money. If I were to add P, that's me actually depositing more money into the account, right? Yeah. Okay. And yeah, so you want to calculate them together, right? Like if you separate them, you're gonna start to run in trouble. So 1061.50 is the value after the first 6 months. So that becomes the initial value. Yes, but you wouldn't then multiply that, right? So if you're saying that 1060, like I haven't checked, so I'm going to trust you, 1061.50 is this number, then when that compounds at 3%, you would get this, right? And you can see that's multiplication. That's not addition, right? So if you want to break it down into two pieces, that's totally okay, but you're not adding them, right? You're multiplying them. Can we do S equals 1 plus 0.4 for account A? Why or why not? Okay, this is actually a really interesting question, Jasmine. So you know, because compounding at 4% is definitely more than compounding at either 1 or 3%, right? Like just compute what S is there, 1,000 times 1.04 to the power of 12. And you'll see it's actually a much bigger number, relatively speaking, than the number that we got, 1267.51, right? So that number is too big. You can't do this averaging of compounding interest because it's compounding, because you're taking interest on interest. There isn't a really good way of averaging what the interest rate should be. And even if you were to do that, you wouldn't want to add the interest rates to each other. You'd want to somehow average them. Okay, so hopefully that makes sense. So for the other account, so for account B, where we do 2% for 12 months, okay, what is the value of the account? Don't give it to me in dollars, give it to me as a formula. No problem. So for account B, maybe let me call this piece of B. We're going to get 1,000 times what, right? Because this is our initial principal, 1,000. Yeah, exactly. 1 plus 0.02 to the power of 12. And if we work that out, what number do we get? And yeah, some of you are still writing, but 100%, good job. 1268.24, perfect. Right, and if you compare these two numbers, this is the bigger one, right? The other one was, you can see it in the yellow up here, 1267.51. So account B is bigger than A, right? That was answer B for the record. So answer is B. All right. If this was an assignment, would we have to write that much, or can we just add the values of the variables? So I would say, like, if it were an assignment, what I would say, like this I think is plenty, right? Like, don't do the number line or anything. And like, it's true, there isn't much to explain here. I might say, there are 6 compounding periods at 1%, 6 compounding periods at 3%. So after 12 months, it's this number, right? It's just a very quick little thing. And it's super crystal clear how you got that number. Do you know what I mean? And then same sort of thing down here. If I said it's 2% for 12 months, then the future value is this number. Clearly B is bigger than A. So just, a sentence here or there. It doesn't need to be crazy. How many significant? Sorry, Aziz, go.
No, I was just gonna say, like, I noticed that a lot. Like, just don't put just numbers and don't put paragraphs. Like, a few steps with like a line or two in between is kind of the way to go. Like Tyler just explained right now.
Exactly. Just a line of, a line or two explaining what's going on in the math, and that's great. So you don't add them together for account A. No, importantly, you actually multiply them, right? So for account A, it's critical that you multiply them. There's no adding going on. Would signs matter, like the dollar sign in our file? No, I don't care if you put a dollar sign there or not. Like, I'm more interested in the process rather than some sort of technical precision on what the currency is. I'm not worried about that at all. Okay, so is that all right? Do we kind of see how that works? Right? And in effect, you're really just figuring out how many compounding periods there are, so that at what percent, so that you can figure out what to multiply your principal by. And if you can get that, you're golden. Okay. Would you want the writing before or after the math? Probably before. Like, you should set it up, right, Michael? So you should set it up, do the math, and then maybe conclude, depending on how obvious your answer is. The reality is you're all, let me just say this. I feel like you're all trying to like meta what writing is, and writing is going to be different, right? Every person is going to be unique and is going to do it in a different way. And there is no one right answer. There's no formula, no template that I can give you. So some of it is going to be trial and error, and that's okay, right? We're going to be a little bit more lenient in the early days about your writing, and then towards the end of the course, we'll be a little bit harsher because we'll have expected you to learn. But, you know, I feel like some of you are trying to template match or pattern recognize, and that's not right. That's not what we're going for here. There's still a certain amount of independent thought that is required when you do this. Okay. I mean, you could circle it if you want, but like, you know, here, if I say, so B is bigger than A, like that, I think that's pretty clear that like, that's my answer, right? Independent of whether or not I've circled it, right? All right, let's get another one going here because we're running out of time. Do I want to do this one? No, we're going to skip that one. Here we go. Let's do this one. Yes. So based off of the lesson that we just learned, right? This is why I want to do this one. Based off of what we just learned, how can we adapt this now in a really abstract environment? So we don't have 1%, 3%, or $1,000. Now it's a little bit more abstract, but it's the same. It's exactly the same lesson, right? So now can we adapt that and do this in an abstract environment? All right, so overwhelmingly, we chose C, and C is absolutely the correct answer. So very good. Like, so for me, honestly, let me tell you right now, this is so awesome to me because, you know, we really struggled with the first question, writing it out. And then on the second question, there was still a little bit of confusion. But I think now after having done 2 of those questions, and now we do this one, which is like abstract and crazy, right? Like, I think if I started with this question, you all would have been like, whoa, that's what the hell is going on? This seems like so unfair. But we built up to it, and overwhelmingly, the majority of you got this correct. Now, for those of you who didn't get it correct, it's totally okay. Obviously, there's still something going on there, and we're going to take this up and hopefully we'll have it by the end. But to me, this is what I'm talking about, right? This is what we want to see, is that over the course of these last couple of questions, I think you all figured it out, right? Like you've figured out kind of how to set these things up, and that's phenomenal, right? That's exactly what I want to see. So that's so cool to me. That makes me really, really happy. So this is question 11. And I'm labeling them here so that if you ever check these, my written notes against the poll questions later, you know, right, which question was which. So what did we say? So we said, let me pull it up so I can see it. So we paid R and 2R. So we alternate interest rates of R and 2R. Now, it's entirely possible just to do this question by counting how many compounding periods occur at R and how many compounding periods occur at 2R. And if you feel comfortable doing that, that's great. You can basically just write down the answer immediately. But let me write it out as a timeline, because I still think this timeline, it's really going to be our go-to thing. It's going to be our #1 tool for figuring out, you know, how to write these things down, even when the cases start to become more complicated. Okay, so let's write down our timeline. All right. And okay, so this is going to be week 1, week 2, week 3, week 4, week 5. My timeline is, you know, a little bit long. So week 1, week 2, week 3, week 4, week 5, whatever. Okay, and then we said we compounded interest rate at the end of the first week. So this is going to be R and then 2R, R and then 2R and then R. And so I start with the principal P, right? And I'm going to push it through. And as I push it through all of these things, I'm going to pick up. So at this point, right, I pick up that 1 plus R, because like I was trying to emphasize at the beginning, right? If you pass through a compounding event with an interest rate R, you pick up that 1 plus R. When I get to here, I pick up a 1 plus 2R, right? When I get to here, I pick up another 1 plus R. So this becomes 1 plus R squared, right? And then here, I pick up another 1 plus 2R. So that becomes 1 plus R squared, 1 plus 2R squared. And then finally, at this one right here, I pick up a final 1 plus R. So I get 1 plus R cubed, 1 plus 2R squared. And that is, we were asked for the end of 5 weeks. So there's my answer right there. Okay. And for the record, I probably, you know, there's not enough writing here, but I'm just kind of showing you because we're running out of time. This is the correct answer. So which one was this? This was C, as we said, right? So this is answer C. like so. Okay. Yeah, there was a typo on the slide. That's what we were talking about in the chat. Okay, so does that make sense, anyone? Is there a... Yeah, so are there any questions about how to do this? Is everyone okay? Can we do more? Yeah, I have another question for sure. We can do another one if you want. Right? I think you like it now, right? Like you feel... right, so what happens, Karina, is like, we're going to do this. And normally what I would do is I would stop at 6, and then from 6 to 7, it's basically office hours. And formally, that's an opportunity for you to watch the videos for next week. And the readings are up, by the way. So if you all want to start looking at the readings for next week, you absolutely can do that. But if there's a lot of demand, and I think a couple people probably want to see another question, yeah, we could totally do it. We could go a little bit long, and I think that's fine. Right? Office hours are recorded. I think I recorded them last time. So yeah, I'm happy to do that. Yeah, and I think you probably get a bit of a high, right? Like when you understand things, you're like, yes, let's do more. I get it. And that's awesome too, right? You like legitimately, you can get a high from, solving problems. And so it feels good to solve problems because you feel good, right? So I totally get that. And that's, as a mathematician, math is a cruel, cruel friend. Right? Yeah, we'll do some more sigma notation. We can do that in office hours. But math is like a cruel, cruel friend, right? Because it really likes to beat you up, and it kicks your butt most of the time. But every now and then you win, right? Like math does its best to beat you down, and you're like, no math, not today. Today is my day, and I'm going to win. So and that feels great, right? It really does feel great. And the question, of course, you have to ask yourself is it worth the payoff, right? Math kicks your butt most of the time, but every now and then you win. Is that worth it? Should you keep it as a friend? Maybe, maybe not, right? But some of us are a bit more masochistic than others.
I stopped at the minor level. I did a minor in math, and that's how much I utilized my life after that. I'm like,
that's right. And then, yeah, and I went and did it for way too long. Yeah, way too long. Well, Zach, I don't see why you couldn't. Totally, yeah, you can do it. Yeah.
With a bit of hard work, anyone could.
Mm-hmm. Whoa, now. No.
It's okay. Tyler, I'm marking the test. I'm putting his name down.
That's right. That's right. You're in the black book now. Don't worry about it, Safe, though. We're not serious.
No, we're not at all.
I mean, at some point, math becomes physics, and that's actually really cool. So for those of you who don't know, I actually did, right? I think I mentioned I did a specialist in theoretical physics as well as applied math and pure math. And the cool thing that happens is there's a very much a point at which theoretical physics and math are effectively indistinguishable. And it's a really cool thing. So really the math begins to beget the physics and vice versa. So it is a lot of fun, right? Is it a wrong approach to make up a value for P and solve it? I would say that's okay. If I said it's a good problem solving technique to say, listen, if there's a bunch of abstract things here, maybe let me make them concrete and try and sort it out. And if that helps you figure it out, by all means, that's totally a valid problem solving technique. But we do kind of eventually want to graduate to the point where we understand why it works for an abstract P. So maybe that's like our stretch goal, but totally, and I have to explain this to my 257 students as well, right? And 257 is like the crazy second year analysis class. It's probably one of the hardest classes in the university. And every now and then I have to explain to them, listen, if you're overwhelmed by the level of abstraction, sometimes it helps to make things concrete, to actually choose numbers or whatever the case might be, right? So that's 100% a valid problem solving technique, right? So I wouldn't worry about that at all. But again, stretch goal, understand how to do it abstractly.
I would say it's a good technique in general, but sometimes it can come back and bite you a little bit, because for some questions, putting a specific number would make the question work. But if you somehow put a different number, you would get a completely wrong answer. So
that's true.
Wrong. So
yeah,
you have to be a bit careful when you're doing that approach. Generally, it's a good way to understand questions, not necessarily as much solving them 100% fully.
Mm-hmm. Yeah, you use it to build an intuition and use that intuition to guide the actual solution.
Yep.
Yes, P is the same for both schemes. No, it's okay. I think it's fine. And if you set a value for P and you get a number and it helps you to understand, I would rather you derive understanding through some level of quote unquote cheating than try to do it correctly and not get anything, right? Like that's useless. If you adhere to the rigidity of like doing it only the correct way and you don't get anything out of it, that's useless. But if it helps you learn, even just as a stepping stone to getting it when you do it properly, that's totally okay. I'd rather have you get something out of it. Is it important to have very capable math teacher for elementary school? Yes. So, I mean, I think the case with a lot of people about why they end up hating mathematics is because at some point they've had a bad teacher, and one bad teacher just screws it up for you, right? Like math is so cumulative that if you have one bad teacher and you don't understand what's going on, then that just snowballs into every subsequent year. And eventually you just get super frustrated. You're like, I don't understand anything that's going on. And it's just because at some point in your life, you had one teacher who like screwed up your foundation. So that ends up being pretty important. There's a lot of interesting statistics that show, for example, being strong in mathematics, even before you go into elementary school, ends up being a high predictor for success. So that's kind of a cool thing too. But yeah, I mean, I think, in some cases I remember in my high school, we'd have like gym teachers teaching math, and they did not want to teach math, but they needed it because they had a second teachable or something. And so they didn't take it seriously. And, students who had to have them for math class really suffered as a result. And I think that's a real tragedy, right? By the way, let's wrap this up in like 30 seconds here and I'll close the polls. But education is such a weird thing, right? And especially high school education. You get a lot of people there who I think are not interested in teaching anymore, who are just show up, kind of do the minimum amount of work and, collect their paychecks. And it's really sad because I, for example, have a ton of friends that I went to school with undergrad who I think would have made phenomenal teachers who really never got a chance to get into teaching because, you've got a bunch of disinterested, disillusioned people who are refusing to retire. So, it's too bad. Curdy, I'm glad you thought it was fun. That's awesome. Really happy to hear that. Okay, so I'm going to close this down. Let's share that result. And great. Again, C, most of you said C, and C is absolutely the correct number or the correct answer. And if we go through this and we try and figure it out, this is a cool thing, I think, right? It says, like, let's actually, let me bring up the question because let's talk about this for a second. Like, this is so great. Like, what does this say? Sorry?
I think I'm unmuted by accident.
Oh, unmuted by accident? Okay, no problem. The thing that I think, well, it's not just that they're worded differently. They're fundamentally different schemes, right, Michael? Like in the first scheme, you do 2%, 2%, 2%, and then you do 10%, 10%, 10%. And in the second scheme, you do 2 and then 10, and then 2 and then 10, and then 2 and then 10. And what this says to you, this is a cool thing. It says that if you trust the math, it doesn't matter the order that you compound. The only thing that matters is the number of compounding periods, right? The order that you compound in doesn't make any difference at all. And the reason for that is mathematically, multiplication is commutative. Yeah, exactly. So I'm kind of surprised that you know what that word is, but like phenomenal that you do. The order of multiplication doesn't matter, right? Exactly. Multiplication is commutative. That's great. Okay, so, but again, let's set it up and kind of let's see why this is the case. So this is question 12. Okay, and so we're going to do this for, so scheme, what do we call it? Scheme 1. So for scheme 1, we've got 6 weeks. 1, 2, 3, 1, 2, 3, 4, 5, 6. And is this the one where we do 2, 2, 2, 10, 10, 10? So 2, 2, 2, 10, 10, 10, right? And so if we take a principal P and we push it forward, we're going to pick up a 1 plus 1 plus 0.02 to the power of 3 and then a 1 plus 0. Well, how do I do this? I don't want to write out all 6 terms. Yeah, exactly. Like, someone tell me if you want me to go through it in more detail. I don't want to write it out for every single step, but I will if it is going to help someone. But again, basically, as you push it forward and you collect them all together, you have 3 compounding periods at 2% and 3 compounding periods at 10%. And so if you put them all together, you get this, right? And for scheme 2, right, you do the exact same thing. Now it's a little bit different here. 1, 2, 3, 4, 5, 6. And now we do 2, 10, 2, 10, 2, 10. So, at any given point, they actually are different. If we didn't go the whole 6 weeks, we actually would get, and we compared the value of the 2 accounts, say in week 3, at the end of week 3, the accounts would have different values, right? But at the end of week 6, they both have exactly the same number of compounding periods in each case. So we are once again going to get exactly the same answer. Right? And again, we're just counting the number of compounding periods. That's the only thing that matters. Okay. And that's how they go. So they end up kind of being equal for this reason. So we look at them, we compare them, we say, yeah, these are the exact same thing. At the end of the day, I collect the 2% together and I collect the 3% together and we get the same answer. So there we go. The number of, like, the order in which we compound makes no difference at all. The only thing that matters is the total number of compounding periods. Okay. Would we always need to draw a timeline? No, I don't think that that's necessary. But timelines really help, I think, as a general rule. And so you don't necessarily want to get away from, even if it's just in your rough work, I think there is value in writing out a timeline, because what you don't want to do is you don't want to like be writing a test and you're like very confident and cocksure and you're like, yeah, okay, 100% I can do this in my head. You do it in your head and you make a stupid mistake because you didn't write out the timeline, right? And you end up getting like 3 out of 10 on the question or something. Like, it's not worth saving that 5 seconds, right? Losing 70% on the question to save 5 seconds isn't a good return on investment. Now, I'll say this to you, even when we used to have time limited tests, I would always say to my students, I think in high school, they taught you to even cut corners to try and go as fast as you could because you were always worried about running out of time. And even when I had time limited tests, I tried to time it. So if you had 2 hours to write the test, it'd even only take you 1 hour. But what I really want to emphasize now is, as we've talked about, you have 24 hours to write the test. Time should not be an issue at all. So I really, really, really want you to try and break this habit of, trying to save time, because time should not be an issue at all. One year we had an assignment or a test where the students all did very, very poorly. No, they're not. So we and Aziz, if you want to elaborate on that. So we had one year where, so we had a year where the test was done very, very poorly. It was the first term test. And I called in a bunch of students and I asked them, I said, hey, I want to know why you felt like you didn't do well. Did you feel like the questions were too hard? Did you feel like you didn't have enough time? Like, tell me what you thought the issue was. So we would go through the test together and we sorted out exactly what the issue was. And so what a lot of students were doing is they would skim the problem, and in skimming the problem would try to identify keywords, and then based off of those keywords would then write down a formula and plug stuff into that formula, right? And again, I think, be honest with yourselves, how many of you are kind of like that and write exams like that, right? You skim the question, you only look at the keywords, and then you try and guess what you're supposed to do. Okay. And I guess that makes sense. Like, that might be a test taking strategy if you're worried about running out of time, right? But the problem is they would skim the question and they wouldn't read it carefully enough. And so they didn't understand what it is that they were supposed to do. And so they did the wrong thing. And then they would get a 0 on it, right? Because they didn't read it carefully. Right. Well, highlighting and solving is okay, but that's not what I'm talking about. Like, they would skim the question and wouldn't actually read the question carefully. And so as a result, they did the wrong thing and got a 0. And that's such a silly thing to do, because the difference between skimming the question and reading it carefully, like, let's say it was 60 seconds, right? And to get 0 on a question because you weren't willing to invest that extra 60 seconds, first of all, is a bad return on investment. But here's the point I really want to make. You don't have a reason to do that 24-hour tests this year, right? Because you'll have 24 hours. You have all the time in the world. You could spend an hour reading the question statement for each question, and like you'd still have, 21 hours to write the test. Okay. So read the questions carefully. And if I can at this point, I know I'm kind of in offstairs and some of you guys want to do some Sigma notation, but one thing I really want to talk about is a little bit of a test taking strategy that I think is super critical. Legitimately, the first thing that you should do anytime you get a test, and it doesn't matter whether it's a math test or an econ test or whatever, okay? The first thing that you should do when you get the test is read every single question and read it very, very carefully and understand what the question is asking you to do. And the reason for this is your brain is phenomenal. Your brain is truly an incredible, incredible device. And it turns out your brain will solve, maybe, your brain can be working on other questions while you're consciously working on the question in front of you. It's 100% a thing. People can and have done this. It's not a guaranteed thing, right? It doesn't work all the time. But it turns out you're working on question 1, but you've read about question 2 and 3. And so your brain, in the back of your brain somewhere, it's figuring out what question 2 is. And suddenly you're halfway through question 1 and you go, wait a second, I now know the answer to question 2. And it's super cool, right? Like that's such a great thing to have happen. But there's no way your brain can do this if it doesn't know what question 2 is, right? So the first thing you have to do immediately at the beginning of the test is put those questions in your brain so that your brain can start processing them ahead of time. And in fact, this allows you to do things like time management as well, because if you look at the questions, you might be like, I know question 1, 2, and 3. I know I can do them. So I know I can whip them out really, really quickly. Question 4 is tough. I'm not certain what to do. I'm probably going to need more time for it, right? So even in terms of your time management for the questions, you need to know what the questions are. Like, what if you got stuck on question 1 and 2, 3, and 4 were really easy, right? Like and then the end of the exam comes, you haven't even started 2, 3, and 4, even though you would have gotten 100% on them. By reading them, you would have gotten 100% on them. Do the questions which you know how to do first. Don't do them in order. Do the questions you know how to do, and then spend the time on the questions you don't know how to do. But again, to do that, you have to read and understand the questions, right? Faizan, does that? Yeah.
There was a few good questions. Number 1, for the final exam, is it also take home or is it timed?
We haven't decided that yet. We'll come to that when we get to it.
That's why I answered. Second thing, I think there was a question earlier saying, doesn't that give us a chance to abuse cheating? Like questions are going to be there as a payoff.
Absolutely. So let me say the following to this one. In terms of abusing cheating, first of all, I'm hoping, and maybe I'm just being foolish about this. I'm hoping that when I talked to a lot of cheaters last year, I would ask them, like, what made you cheat? In a lot of cases, it was desperation, right? A lot of cases, it was, you didn't feel like you had enough time, or, you didn't feel like you'd studied enough, whatever the case is. The hope is that with 24 hours to do the test, that it relieves some of that stress and some of that desperation. And that as a result, you're less inclined to cheat. That's my hope. And I hope that you all prove me right. Okay, that's my goal. The other thing I want to say, though, is we are really good at catching cheaters.
I was going to say, it's actually easier than you guys think to find them.
We're very, very good. And I really don't want to do it, but please don't make me, right? So, yeah. Yeah, exactly. And Aruba, and has been kind of answered before, I'm going to give you a PDF that has all of the questions on it. And it's going to be like CrowdMark. So it's going to be exactly like an assignment. Okay. The test is basically a 24-hour assignment. I'm going to post the assignment on Quirkus. You are going to have access to all of the questions at once. And then I'm going to create a CrowdMark link. And when you answer the questions, you can upload to CrowdMark, right? And so you have access to all of the questions at once. What I want to say here, though, here's an important caveat to this as well. Because you have 24 hours to upload your solutions, if you are a minute late, you unfortunately get 0 on the test. Okay. Yep, you have you have 24 hours to do the questions and upload them. There's no reason you should be late, right? With certain, like if you live in a place that had, you lost your internet for 3 days straight, totally find a way to email me and we'll figure it out. But if you're late because you left it to the last minute, that one's on you, right? Also, CrowdMark lets you upload. And then before the deadline, if you want to re-upload, like change your answer or do anything like that, you absolutely can. So as soon as you finish a question, you should upload it just in case, crap hits the fan and something catastrophic happens. You get in a car accident or something, who knows? But, upload early and upload often and re-upload as you go if necessary, right? It's better to have something in there in case, something goes wrong. Okay.
For just a quick rule of thumb, if the deadline is by 9 p.m., if I was you guys, I would not upload anything after 8 p.m. Like give yourself an hour buffer. Like in your head, make it like a 23-hour exam rather than 24-hour. I know it sounds trivial, but because especially in the last half an hour, a lot of people try to upload at once, and a lot of times the system crashes and you're going to be like a few minutes late, and it's just not worth the headache.
I can see when you all start uploading, and it is phenomenal, even for your assignments, how many of you start uploading 3 minutes before midnight, right? and then something happens, like your Wi-Fi craps out or your clock doesn't agree with the server clock, and then you're late by a minute. And I have to say, well, listen, you've had a week to upload this thing. Why are you waiting until 3 minutes before the deadline, right? And again, I get it. Stuff happens. If a tornado hits your house, 100%, we're going to figure that out. Don't worry about it. We're not dicks. But if you're late because you were silly and left it to the last minute, that one's on you, right? So don't worry about that. We're going to figure it out if something serious happens, but don't abuse that, right? Is all I'm trying to say. You got to have a little bit of self-responsibility here. And so that's the goal, and that's how we're doing it. And I'm hoping that, again, that makes your lives a little bit easier. And that's the idea.
We have a raised hand. Brianna has her hand raised. I think she has a question.
Sure. What's up?
Sorry. Can you hear me?
Yeah.
Yep.
Yeah, I don't mean to distract from talking about the quiz, but I was wondering about the writing assignment.
Sure.
I don't really know how to phrase it in writing. So when I was reading the description, it seemed like you guys are mostly grading on effort because the concept may be slightly beyond what we're supposed to understand. But when I looked at it, it seemed like I could mostly gather what was going on. So I don't know, in terms of when we get the writing assignments, where should we be in understanding for the actual problem?
Okay, so actually I've tried to make the problem such that they're not trivial, but you can solve them pretty quickly. So it's not that they're supposed to be actually beyond your ability. It's supposed to be that you can solve them with a little bit of effort, but not so much effort that it takes you a ton of time. Basically you should spend 10, 15 minutes actually solving it.
All right, perfect.
Right?
Thank you.
Yeah, no problem.
We have another raised hand.
Okay.
Sanjay.
Professor, if you have time, would you mind explaining a question that I'm stuck on?
Sure.
Okay, it's 2.3 from the PDF, from the notes PDF.
Okay. All right. Okay, so let's kind of do the following as we transition more here into office hours. Give me about 5 minutes just to fill my water bottle and do whatever.
I'll be around to answer questions.
Perfect. So Aziz will answer your questions for a second. Just give me 5 minutes here, and I'll come right back, and then we'll dive into it and do whatever you want. And then if you have any questions, get them ready, and we'll talk about them.
Yeah, don't worry. I'll guide them from this point.
Okay, perfect. Thanks. So I'll be back in about 5.
So here I saw a few questions. The writing assignment 1 link has not been up, is not up in CrowdMark right now. I think Tyler will open it up I'm assuming by tomorrow or so, or in a few days he'll have it open. And when he does that, he'll send you guys an email, and you guys you should be able to see it by then. I got another question here. Can I use a sentence or two to answer assignments on question 1? A few sentences is fine, as long as it's kind of coherent, right? You want to, the whole goal is to mix the math with a few sentences just to make a coherent solution overall. As long as it's clear and coherent, then it's, that means you're doing a good job there. Is every Thursday class 6 to 7 is office hours? Yeah. So usually that's going to be the format on Thursdays. The class the actual class is going to be from 5 to 6, and then the office hour is going to be from 6 to 7. What's my favorite fruit? By far, easy answer, it's watermelon. So if anyone has a different answer, you guys are wrong. There's a few raised hands here. I think Kurti, you had your hand raised first. You can unmute and ask a question.
Hi. So I had a question for the assignment 1.
Yep.
So for numeracy 3, number 3 and 4, I know the answer, but it asked me to justify my answer in 2 sentences. Is that possible to do that showing like work that led to my answer and not exactly?
Well, it should be a bit of both, right? Like you should have work and then two sentences explained. The only reason we put a limit is just so you don't end up writing like 3 pages worth of explanation. That's the only reason. But show your work and then a few sentences and you're good to go there.
Right. So like, what if I use like trial and error to solve for my answer? Would that be acceptable?
I mean, it's a case by case dependent basis. So like when you look at your solution, you should be able to tell if that's like a sufficient solution or not. But if you end up using it and you think it's like, sufficient enough, then you just want to kind of explain it. Go like, I used trial and error and I did this, this, and that, and I did this and this and that. I can't give you much more than that just because it's an assignment. If this was just a textbook question, I'd obviously give you a lot more detail. But since it's an assignment, I can't give you a lot more detail than that, unfortunately.
Okay, thank you.
No problem. I think, Ken, you had your hand raised next.
Hello, Kai, can you hear me?
Yes, I can. What's up?
So my question is about writing assessment. So do we really have to handwrite in the word, like the short answer, like the first part, or I can type it?
Honestly, you could type it, you could write it however way you want. As long as it's clear and obvious and you have all the information necessary, I really don't care how you do it. Some people like to use that like a tablet and write it on a tablet. Some people do it by hand. It's up to you. I don't care.
Yeah, because I was thinking about like the number part is hard to type it out, so I can write that with hand. And the word part, I would like to type it.
Honestly, it's up to you. Whatever makes your life easy.
Sounds great.
Fine with us.
Okay, thank you.
No worries. When our TA hour is going to be posted, office hours going to be posted, probably within the next few days. The TA office hours are going to be there for the next few days. We're going to post them and they're going to start next week. So you're going to see us. I'm going to have my office hours as well. So you guys are more than welcome to join to ask me any questions as well. Just out of curiosity, for the people that are still around here, how many of you guys are trying to get into commerce or management? Like, can I just get some yeses in the chat if you're trying to get into commerce or management? Okay, maybe some. If you answer no, if you are not, if you're trying to get something else. Okay, I see a lot of yeses in the chat. Okay, well, that's fair. Do you guys know if you want to go into management or in commerce, you want to get into finance, accounting, marketing? Does anyone have an idea, or are you guys just trying to figure it out still? Okay, human resources, finance, accounting. It's a good mix. Management, commerce, either accounting, finance, commerce. Okay, I mean that's fair. That's kind of down my alley. Two things. So I did. What's your major? Yeah, you're definitely allowed to ask. So I did a specialist in finance. So I did a Bachelor of Commerce. I did a specialist in finance with a major in economics and a minor in math. I graduated in 2018, and like ever since graduating, I've always been teaching on the side after hour, like in the evenings. During the day, I work. I used to work first as a financial analyst as soon as I graduated, and now I work as a consultant at Oracle. That's my full-time job, and I teach part-time. Yeah, I teach part-time. That's why I only teach in the evenings. How did you major with a specialist? I mean, you're gonna realize this very soon, but when you do a specialist in either finance or accounting, the major in economics is only like 1 credit away. So you just take 1 extra econ course and you pretty much have the major. So it's not really that special, but it just sounds cooler than it actually is. But like I know what you guys are going through because I've been through a lot of what you guys are going through right now. No, if you have a specialist, that's more than enough. You can just specialize and that's perfectly fine. But I would always recommend the major in economics, and they will recommend it to you guys as well because you're only half a credit away. 6 to 7 is on Tuesdays is also an office hour. Yes, so Tyler has office hours on 6 to 7 both on Tuesdays and Thursdays. This one shows up as inherently in a lecture, but he splits them up as always. The first hour's lecture, the second hour's tutorial. That's kind of like the inherits on here. My UFT email is not working, so I'm supposed to submit an assignment. Just email Tyler. Just email Tyler with your personal email. I think that's the case, right, Tyler? If they don't have the UTOR email is not working yet, for
Yeah.
CloudMark.
Yeah, so basically you can just email me and get away with it, but I linked that the page specifically, which says exactly what you're supposed to do. There's a big section that says if you do not have your like link.
Just one last question before I can let you kind of go through. I got this a few times. The question is, are we not allowed to, are we allowed to get help or work together in order to solve assignments? So this is like a slippery slope a little bit, because obviously you're allowed to work together in terms of just bouncing ideas off one another. But when it comes down to actually solving the assignment, you should be solving it individually. Because a lot of the time what happens is when people try to solve it together, you guys just end up copy pasting each other's answers, and that's considered an academic offense. But if you're just discussing the question from like a kind of a broader perspective, then by all means you can kind of bounce ideas back off one another. But I definitely wouldn't recommend sitting there and just solving it together, because it tends to be just a copy paste of the same assignment, and then we end up flagging those for academic offenses down the line. So that's not necessarily the best idea. But definitely, if you want to bounce ideas off people and talk to people about assignments, then by all means you can do so.
Yeah, right. Like math shouldn't be done by yourself. Okay, so an assignment, if an assignment takes you like 8 hours to do and you work with a partner, it'll take you like 2 hours to do. But yeah, what you don't want to be doing is like writing together, because then your assignments will be identical, right? But totally, if you're like, hey, I'm stuck on question 1 here, what did you do? And someone's like, oh, maybe try this. And then you go off and you do it and it works. That's phenomenal, right? Like totally help each other out and give each other, like, I really want you to and encourage you to work together, but you have to be so careful about not copying from each other, right?
How about just checking answers to make sure you're doing it right?
Yeah, if you've both already written up your solutions and you're just like, hey, like, how did you do this? And you kind of, you have to be careful. Technically, even showing your solutions to another student is an offense.
No, I mean, like just the answer.
Yeah, you got like 17 or something. Yeah, that's totally okay. Yeah, whatever. Yeah, that's fine.
Thank you.
That's fine. Yeah. The problem is a lot of times when people look at each other's answer and like inherently people like just then change their solution to that what they see.
Yeah.
And the problem is when we start marking them in CrowdMark later on, like after you guys submit them, and we go through a few assignments that look pretty much like identical. It's like someone just copy pasted their solution 4 times. We end up flagging them, and then you end up getting in trouble for something, even though you might have not purposely done it, but you will get in trouble for something like that. So I would try to avoid like kind of just discussing answers as much as discussing processes when solving mathematical questions in general.
Yeah, and like a nice rule for this is when you're actually writing your assignment, there shouldn't be other people around, right? Yeah, I mean, you can like leave whenever. Like you don't have to be here for a lecture even. So, but yeah, I'm not going to cover any more lecture material. This is basically office hours. So if people like ask questions, you might miss that, but this seems to be recorded anyway. So it'll be uploaded. But yeah, I mean, I'm never going to force you here. I don't take attendance. You can leave whenever you want.
Emma has her hand raised.
Emma, what's up?
Hi, I just had one question regarding the assignment that is due tomorrow. I'm done with it, but I don't know anymore, because for numeracy 3, for the first 2 questions, they're quite straightforward. So I just did the math, but I literally don't know how to explain it in words because it's just math.
So right, it's not that, for example, that we even need a paragraph or something. What you might want to do is something like, a line that says now on to the next iteration, or something like this, right? Or in the case where you're solving something, give us a little hint about what you're solving, like now taking nth roots or taking a logarithm, right? Just like a small comment beside your math, which helps guide what it is exactly that you're doing. That can be infinitely beneficial, right, to somebody reading your stuff. And then when you transition from doing one calculation to another, you usually just want a short little blurb, like half a sentence explaining that now you're transitioning to a different calculation and what calculation you're actually trying to do. Does that make sense?
Yes, it does.
Okay.
It's just very different from high school. So
yeah. Shanze, you have your hand up as well?
Yeah, before you left asked to solve a question, I think you forgot maybe.
Oh, yeah. No, the 2-3, was that you?
Yeah.
Yeah, sure. It's just we kind of got consumed with other things. Okay. Yeah. So admin questions, everyone throw them in the chat. And Aziz, you actually can go, but it's up to, I'm not going to force you to stay.
No, it's okay. I'll hang around.
Okay. So, yeah.
I have a question. One more question.
Okay.
So for the explanation, so after each step, we put like a short explanation, or do you do that at the end after after you lay out the entire?
It's up to you. It depends on the question, right? There isn't like a one solution fits all. If the answer is obvious and you're done, great. Otherwise, you can put a concluding sentence and be like, so what we wanted to be true is true, and here it is, right? And you also don't have to include an explanation for every single step. In fact, you don't have to include every single step. When we say explain your steps, we're not saying give us every single step. We don't need to see you do like really simple algebra.
Like
right?
2 plus 2 is 4.
Yeah,
it's fine.
So remember, everyone, keep in mind here, what you're trying to do is say you're trying to convince your audience is somebody else in the class who knows as much math as you do, right? They don't know the solution, but they know as much as math as you do. So if there's some math which is absolutely trivial, you don't need to do 2 plus 2 plus 4 and explain that to us. And even like fairly simple algebraic manipulations, we all know how to do it. You don't have to explain them. It's the non-obvious things, right? Or if you find that you've got a long calculation, just even providing little prompts to remind us what you're doing at every point, those are the sorts of things that you want to do. So when you're looking at your assignment, try and clear your brain and say, listen, if I were another student and I didn't know what the answer was, could I read what I wrote and would I understand it, right? That's how you should be able to assess whether your writing is okay. And that's all you're trying to do. Okay, so let me get to Shantae's question because it was asked a long time ago and I don't want to act like I'm ignoring. So, okay, yeah, 2-3. So this came up a couple of times on Piazza, and this is a great question. I really do love this one. So this is 2-3 from the notes. And it says, suppose you invest in a bank account which compounds at an interest rate R at the end of each month. Okay, so rate is R at the end of each month. Okay. On January 1st, you invest P dollars. So Jan 1st, right? We're going to invest P dollars. So I'm just writing this so I have it in front of me, and then I'll show you how I'd actually write it. February 1st, we withdraw P over 2. February 1st, withdraw P over 2. And so on. So March 1st is P over 4. April 1st is P over 8. Okay, so March 1st is P over 4. And April 1st is P over 8. And how much is on May 1st? Right, so how much is on May 1st? Okay. So we're going to do this one step at a time. I think that there were a lot of people who asked on Piazza, they're like, I see what the final answer is, but I'm really, not certain how you got this. So again, let's draw a timeline. I think a timeline is really going to save our butts here. So here's January 1st, February 1st, Feb 1, March 1, April 1, May 1, and June 1. Actually, I don't need June 1, do I, right? Did I get my months in the right order? January, February, March, April, May, June. Okay, whatever. We don't need June. So I have P dollars here. And I'm going to come through and without worrying about withdrawal, okay? No, don't worry about the withdrawal at all. How much money do I have on February 1st? Okay, ignoring the withdrawal. Okay, throw it in the chat. Exactly, yeah. Okay, so P times 1 plus R, exactly. So we've got P times 1 plus R. Okay, now the question says that I'm going to withdraw P over $2 here. So if I withdraw P over $2, how much money is in the account? This is the critical bit that I think most people make a mistake on. Exactly. Beautiful. So we're going to withdraw. And when we withdraw, you subtract, right? Like if you had, some people were doing like dividing the number on the left by 2 instead of subtracting P over 2. But think about this. If you had $300 in your account and I asked you to take out 50, like what would you do? You would subtract $50 from your ledger, right? You wouldn't like divide that number by $50. Like that's not what you're trying to do, right? So you're going to subtract. So this is the current amount of money in our account, right here. This is the amount of money we have. And now I'm going to push that and we're going to go to March 1st. Okay. So on March 1st, ignore the withdrawal. Okay. Don't worry about the withdrawal for now. How much money is in the account on March 1st? And this one takes a little bit longer to write out. So that's fine. I understand. And if you get this, I think you're set to do the whole question. Right. Okay, exactly. And so everyone, if you're not certain about this, this is the time to ask. Right? Does this make sense? And the reason is, right, the amount of money in the account is the thing that I've circled in blue. And when I take that and push it through a compounding period, it picks up. Okay, so Curdy, yeah, so this is what I'm saying. When you take that amount and you push it through a compounding event, like March 1st or at the end of March, we pick up the 1 plus R, right? Every time you pass through a compounding event, you pick up the 1 plus R. Does that make sense? Okay, great. So let me maybe expand this out a bit. So this is going to be P times 1 plus R squared minus P over 2 times 1 plus R. And now when I withdraw P over $4, what is the amount in the account? Like, what do I do? You don't have to write the whole thing out. Just explain to me what I'm going to do. Right, subtract P over 4. Exactly, P over 4. Okay, so this is now currently, oops, circle's going to be too big there. This is the amount of money that is currently in the account. And you can see, wait, where are you? There's an objection to a parenthesis, but you don't have to put in the parenthesis. Depends on what you mean by that. So here I expanded it out because I could have just written this as like, you know, minus P over 4 here, but I like to expand that out. So I don't know, Curdy, if that was like what your objection was. And if not, please elaborate so that I can answer the question. But I did want to expand that out before I subtracted, just because it was a little bit, it's going to be easier to see the pattern, I think, as we go down.
Can I unmute?
Yeah, of course. Yeah.
So like above it, you put in parentheses the first step, which is P times 1 plus R minus P over 2.
Okay.
So like, doesn't that have to stick together? And then after you get that answer, you multiply that by 1 plus R.
Okay, hold on. So this is, right, so this did all stick together, and then I did multiply it by 1 plus R. Is that?
Yeah.
So that's okay, right?
Yes.
And so then what I did is I just, like, I don't have to stick it together, right? Like mathematically, I can expand it if I want. And I'm going to do that just because I think it's easier to see the pattern. But if you wanted to, you could totally just keep it like this.
Okay.
Right. And so one thing you could actually do, so I'm going to expand the 1 plus R in. And when I do that, I get that, right? That's okay?
Yeah.
Okay. Now you're right. I don't have to do that. I could leave it like this line right here. And why not? I'll follow that along. You know what? I'll do both of them and I'll bring them along. So, but did I answer your question or?
Yeah, that makes sense.
Okay.
Thank you.
Okay. So now when I push this into April, like I'm running out of space here, but hopefully you see what's going to happen. This is the amount, right, that's in the account. So when I push through the compounding event at the end of March, beginning of April, I'm going to pick up another 1 plus R. So I'm going to multiply that whole thing by 1 plus R. And I'm going to write it over here. So if I if I were to keep it without expanding the bracket, I would get this. And hopefully you'll see why I wanted to expand it. Right? Which looks, I think, pretty gross. Louise, exactly. You multiply by another 1 plus r. So this looks kind of gross to me. But if I were to do it using the bottom expression instead and expand it out, then it becomes 1 plus r cubed minus p over 2, 1 plus r squared minus p over 4 times 1 plus r, right? And that's the same thing. If you were to expand these two expressions out, you get exactly the same thing. I think the bottom one, though, is a little bit nicer. It seems to have a lot more symmetry in it. It's aesthetically more pleasing to me, right? So that's just the amount of the value in the count, and then we would subtract another p over 8, right? And so it asks us then what the value, and then we have to do it one more time, right? So one more time at the end of May 1st, we push it forward, we pick up another compounding period. We don't withdraw another amount though, but we push it to the end of May 1st, withdraw another compounding period, and that will give us our final answer, right? And I think, how do I know it's raised to the third power? Okay, so it's this that here, let me maybe write that out in a couple more steps. So if I take, what I'm gonna do, I wanna take this thing and I'm gonna multiply the whole thing by 1 plus r, right? P over 4 times 1 plus r. And when I expand that, I'm just going to collect it with all the other 1 plus r's, right? Because there's already 2 1 plus r's here. So when I multiply by 1 plus r, I'll get 1 plus r cubed. 1 plus r cubed, 1 plus r squared minus p over 4, 1 plus r, right? Yeah, okay, great. And then I do my final thing of, getting rid of another p over 8. And then this isn't the final answer because the final answer wants it one more month from now, right? Yeah, wait, Louis, be careful about your brackets, right? You don't want to write the wrong thing there. But when the question is actually asking me to push it forward one more time. So there isn't another withdrawal, but there is another compounding period. So everything is going to pick up another factor of 1 plus r. And I think if you check the answer in the book, that's the one it gives you, right? So does that work out? So let me just say after one more compounding period. So after one more period, that will give us, right? We just keep picking up these factors of 1 plus r. 1 plus r cubed, p over 4, 1 plus r squared, p over 8, 1 plus r. Okay, and that's our final answer. 119, sure. Let me just make sure we're okay with this though. Are there any questions?
We have a few raised hands. I'm not sure if it's relating to this question or something completely different.
Okay, so Shanze, you first of all, is your hand just left over or?
Oh yeah, sorry.
Okay, sure, no problem. Just checking. Rafid?
I have a problem with question 1.18d. I'm not sure how to go about solving it.
Okay,
and
so
I actually wanted to confirm if the answers for A and B are the same. Okay,
so D and then is A equal to B. Okay, so let me do Zainab's question first, 119, and then we'll come and we'll do yours at 118, okay? So Zainab, do you have a particular 1 in 19 that you want to do? Because once you kind of get the feel for one, I think they're all the same. So I don't necessarily want to do them all.
Just A is fine.
Just A is fine? Okay, cool. So 119, so this is 1-19A, and it says to evaluate this expression. So the sum from K equals 0 to 10 of 2 to the K plus 3 to the K plus 2. Okay, and then just as an aside, so we know, right, we'll remind ourselves of the formula for a geometric series. R to the K, this is 1 minus R to the N plus 1 divided by 1 minus r. Okay, because we're going to need that. So I want to be able to apply this formula, but unfortunately, I'm not in a position where I currently can, right? Because this sum, the sum over here in white doesn't look like the sum over there in left. But what I can do is use this nifty little fact about sums, which is that I can split this sum above here into two sums, 0 to 10 of 2 to the power of k, plus the sum from k equals 0 to 10 of 3 to the k plus 2. Okay, so that's a nice little thing you can do. And if you think about why you can do that, it's basically just the statement that like a plus b plus, or let's say a1 plus, a1 plus b1 plus a2 plus b2 is the same thing as collecting together the a's and the b's, right? And if you're worried and you're like, hold on a second, did you even tell us that that was true? The answer is yes. This fact is at the top of page 24, right? So at the top of page 24, this fact is explicitly stated. But if you're trying to convince yourself about why it's true, it's basically because you can just rearrange addition in any way that you want. Okay, so we're in a good place for this thing, right? This thing looks like our thing in yellow in the top right-hand corner. So we're not worried about that. We can probably figure that one out. But this one here, this thing is still giving us a little bit of trouble because it doesn't look like just r to the power of k. It's got this annoying +2 thing in it, right? Could I demonstrate a downshift while solving this? Well, there's no reason to do this one as a downshift because it already is exactly where I want it to be, right? Like it already starts at 0, which is where I want to be for the formula. And both of the sums have the same index. So I don't, like I could show you how to do it, but it's not actually advantageous for us here. Sean said, could we separate it out by using the exponent rules and factoring out the 3 squared? Absolutely. That's exactly what we want to do. Perfect. So what we're going to do is we are going to write 3 to the k as 3 to the k times 3 squared, right? Those are the exponent rules. And now this term right here, it doesn't have any k's in it, so it can actually be factored to the outside. K equals 0 to 10, 2 to the k, and then I can take it out like that. 10, 3 to the k. And now I'm in a position where I can apply that formula above and use it, right? Use it twice. So if I do, what am I going to get? What am I going to get? I'm going to get 1 minus 2 to the 11 divided by 1 minus 2 plus 3 squared, 1 minus 3 to the 11 divided by 1 minus 3. And you can work that out if you wanted. You should do obvious. We're going to get this question eventually, so now it's worth talking about it. Should I simplify it? Do I need to simplify my answers? To which the answer is generally no, but you should do the obvious simplifications, right? So the obvious simplifications in this case, 1 minus 2 is -1. So plus what? 9, no, plus 18 times 3 to the 11 minus 1. Right, and don't worry about doing it any more than that. That's perfectly fine.
What did you do in the last step?
Sure. Okay. Okay, fair. I did a couple of things. So I wrote 1 minus 2 to the 11 divided by 1 minus 2. So that's 1 minus 2 to the 11 divided by -1. And then instead of keeping that as a fraction, right, I just flipped the signs of everything. Does that make sense?
You divided it by.
Yeah, I mean, dividing by -1 is the same thing as just multiplying by -1, right? Like it just flips the signs of everything. You might have to think about
like why you're doing this.
Well, because I don't want like 2 minus signs. I mean, I guess if you wanted to keep it like this, you could, but it's kind of gross.
It is very gross.
You know what I mean? Like, okay, how about this? 1 minus 2 to the 11. So if I take the minus sign upstairs, I get this. And then, of course, you're not going to keep that as a fraction, right?
If you just try like if you put like multiplying by -1 in the numerator.
Yeah, sure. And the denominator.
And yeah, and to the denominator to both. the -1 will make the first one a minus, and then -2 to the power of 11 becomes +2 to the power of 11. And then he just switched around.
And so my question is like, which of these looks better, right? Like definitely, I think the one on the right does.
But you're right, it's 9/2. It's not 8.
Oh, you're right. You're right. It is 9/2. Thank you. You're absolutely right.
That's what happens when you skip a few steps.
That is what happens when you skip steps. So this one is 1/3 to the 11 divided by 1 minus 3, which is 1 minus 3 to the 11 all over -2. Again, I'm going to put the minus sign upstairs because, right, why have more minus signs than you need? And then there was already a 9 in front, so you just factored those out. Yeah, but thank you two for pointing out that I made a mistake there. Okay, so does that make sense? I'm sorry, I forgot who asked, but
I'm just confused at the part like how did you like change it to a positive?
Okay. Here, yeah, let's try it a different way. So let's do it with this one, -2. So what I'm going to do is I'm just going to multiply top and bottom by -1. Right? So that gives me -1 times 1 minus 3 to the 11 divided by 2. That will give me -1 plus 3 to the 11 divided by 2, which is 3 to the 11 minus 1 divided by 2. Right? Is that okay? Does that make sense? Right? But basically like, yeah, the minus sign just means flip the signs, right? So if I take the sign from the minus in the bottom and put it upstairs, like I could basically just write, right? I could write this as -1 plus 3 to the 11 divided by 2, right? Because it flips the sign. But then again, I also don't want to start with -1, right? So I just write it as 3 to the 11 minus 1. Yeah, so that's the idea there. Right? Again, if you don't want to do those steps, it's not crazy necessary. Okay. So 118D. So again, we are told same formula as above. Let me repeat it just so that we have it in front of us. AR to the K is A times 1 minus R to the N plus 1 divided by 1 minus R. And the question is, what is the sum from K equals 0 to N of AR to the 2K? Okay, so any ideas?
I remember this question.
Good. From what?
From like I remember the first time I saw this question was 5 years ago.
Nice.
On your first ever assignment. But
nice.
Anyways.
Do we substitute R squared?
Sure. Yeah. I mean, like, it depends on what you mean by substitute, but I think you do have the right idea. So let me kind of rewrite this suggestively like this, as like R squared to the K. Is that kind of, and then we're going to treat this
S equals to R squared.
Exactly. Exactly. Yeah. So let me maybe call this S's everywhere in the formula. And then we'll be like, let S be R squared, right? And so now we get the A is the sum from K equals 0 to N of S to the K. And we can use our formula. So we get A times 1 minus S to the N plus 1 divided by 1 minus S. But of course, we want our answer to be in terms of R, not in terms of S. So we're going to plug that back in. 1 minus R squared to the N plus 1, 1 minus R squared. And yeah, you know, we can do a little bit of simplification here. 1 minus R to the 2N plus 2 divided by 1 minus R squared. And I would, you can cancel a 1 minus R squared from this. I wouldn't worry about it. But you can factor an R squared out at the top. So, but again, don't worry about it. Okay, so does that make sense for 18D? Yeah. Okay.
Yeah.
And then there was a question of whether A was equal to B. Oh, okay, this is an interesting question. I like this one, right? Like, are A and B equal? Okay, so
if they have the same solution.
Yeah. Okay. Well, I actually can't just kind of do it off the top of my head. So let me just take a look here. So AR to the K. So this is going to be AR 1 minus r to the n plus 1 divided by 1 minus r. And then b is the sum from k equals 0 to n minus 1 of a r to the k. So this is going to be a times 1 minus r to the n divided by 1 minus r. So no, right? They are a little bit different. Oh, no, sorry. This should be r to the n here, right?
I got these answers.
You got the two answers I got?
Yeah. And for C, I got just n minus 2.
Right. Yeah, which is basically like a combination of A and B, right?
Thank you.
Yeah, no problem. But these are different, right? Because you can see like this one has an R in it.
Yep.
Yeah.
Oh.
Right. Like, so for example, if we downshifted A so that it started at 0, right, then we would get the sum from k equals 0 to n minus 1 of a r to the k plus 1. And so you can see like these are definitely different sums, right? Because the difference is the k versus the k plus 1. And so somebody asked about downshifting, so hopefully that helps there. Okay, anything else, anyone?
Can I take a quick picture, a screenshot of
the
sure.
Answer? Yeah.
Thanks.
And it's recorded too, right? So like in the event that everything exploded suddenly, it'll be uploaded a while.
I know we only have 5 minutes left, but do you mind doing another one?
Sure.
2.4, because it also has sigma in the answer, and I don't know how we got there.
Okay, let me pull it up here. 2.4. Suppose you invest in a bank account, which comes to yes. Yes, very good. Not sure why the R is there in 18A. Yeah. I mean, like, I cheated and wrote this as how do I want to explain this very quickly before I go to the next one? So
sorry
if you
I'm interrupting. When I tried to do A, the R got like it was like n minus 1 plus 1, so there was no R outside, I guess.
Okay, here, let me do this one a little bit more carefully. So if I factor an R out of this, so I get A, well, let me factor the A out too. So I get K minus 1. And then if I downshift that, so I get K equals 0 to n minus 1, R to the K. And now if I use the formula, right, I get 1 minus R to the n minus 1 plus n, like that. And that's what I had before, right? So is somebody still, are we upset about this still?
There's a formula given in the question, which I actually was trying to use.
Yeah, so the formula in the question has n plus 1, like that, right? Yeah. And the minus 1 and the plus 1 cancel out, so we would just get n. But that R in front is still there, right? It doesn't go away. Isha, I'm glad, happy it makes sense. Okay, 2.4, this is a good one. And this is really gonna pivot nicely into what we're gonna do, not next week, but the week before. So, the week after. So 2-4. So you invest in a bank account, interest rate, so R monthly, let me just write that down. So R percent monthly. And on January 1st, you invest P dollars. And then continue to invest P dollars on the first of the month for every year. Okay, so, February, I got to make them smaller. February, March, April, May, June, July, August, September, October, November, December. Okay. So now the important kind of point here is, unlike our usual scheme, where we just invest an amount of money at the very beginning and let it grow, right? We are now augmenting our investment by adding money in. Yeah, A and B like that, sure. Okay, so first of all, let's make sure that we are all clear about what the difference is between 2.2-4 and a normal scheme, right? So what we've talked about up until now is you invest the money and you just let it sit, and it goes through several compounding periods. But now you invest money on January 1st, then on February 1st, and then on March 1st, and so on and so forth, right? So you're constantly reinvesting. And this is now actually going to change things, but it changes in a way that's actually very similar to 2-3. So when we did 2-3, we were withdrawing from the account, right? Which meant we were subtracting money, but now we're going to add to the account, right? So we're putting more money in. So at the end of the first month, our initial principal is going to be 1 plus R, right? But we are now adding P dollars. So what do I get? What is the total amount of money in the account now? Like, what do I do? So in the previous, we were withdrawing, right, exactly, plus P, right? Be careful, Curdy, right? Because we're just adding P in, right? We're not somehow doubling the amount of money in the account. We're just like adding $100 each time, right? Okay, so now here, right, this is the amount of money in the account. So when we go to the next compounding period, we multiply everything here by 1 plus R. And then we add another P, right? This is from the deposit. And then the next month, we pick up another 1 plus R on everything. And then we add in a new investment. And hopefully you're starting to see there's a sum here, right? So if you keep on doing this, yada, yada, yada. So let's see. So after the first month, right, so we're going to start at 0 to the 11, P to the 1 plus R to the power of K. Right? Like, this is going to be annoying, but if you actually wanted to write it without sigma notation, you've got 12 terms that you have to write down. But you could do it if you really wanted to. But this is the reason why we made you do sigma notation before. Shanze, yeah?
Why won't it end at 12? Because isn't our last power going to be 12?
Right. Okay, so interesting. So when I get to here, right, I have some huge string of discussing things that I've done. But the power of this thing is how many compounding events this has gone through. Actually, is it going to be 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, all right. So take this principal P and count how many compounding events it's passed through by the time it gets here, right? Just count the number of R's it's gone through.
Error is 11.
Yeah, it's 11.
Right? And so that is the principle that's grown the most, right? So if you can imagine, if we didn't do any of these other principles, right? And we said how much money is in the account at the end of the year, it's P times 1 plus R to the power of 11.
Mm-hmm.
Does that make sense?
Yeah.
And then this one right here picked up 10 compounding periods. And this one picked up 9, and this one picked up 8. So the first, the biggest term is 1 plus R to the power of 11. And then the smallest one is the very last investment that we made.
Okay, I get it now. Thank you.
No problem. And then so when we write that as a sigma notation, that's what it looks like. And in fact, hopefully you all see this is actually a geometric series. So you can guess what's going to happen next. You're actually going to plug this into the formula for a finite geometric series. And this is going to allow you to calculate the amount of money you have at the end without having to compute each of these sums, right? You'll just be able to plug your numbers into a formula and you'll get a final answer. Okay, everyone. But that's a preview. Like these are what this is called is an annuity. So we're going to get to this eventually when we get to annuities, but this is kind of a nice place to start and just to start to mess with it and see how it's going to come in. But if you ever needed an incentive to be okay with sigma notation, hopefully this is it, because this is what the course is going to become. Because of course this is what happens in real life, right? You don't just plop a huge sum of money in and then let it grow. You actually continue to contribute to the principal over time, right? So it's going to get a little bit more complicated, and we're not going to be able to avoid sigma notation. All right, everyone. So that takes us to the end of lecture. Hopefully I managed to nail down all of your questions. But, if you have any more, please don't hesitate to throw them on Piazza. Again, I think if you've been on Piazza, I'm pretty quick at answering, except on days where I'm like crazy busy, like Tuesdays and Thursdays. Otherwise, don't forget there is an assignment due tomorrow. So, work hard on that. Don't leave it to the last minute. If you haven't started it, please make sure that you start it sooner rather than later. Because if you get stuck, you want to be able to ask us questions, right? And then other than that, have a great weekend. And I hope to see you all on Tuesday. Okay, so thank you, everyone. See you later. Thanks, Aziz, for hanging around for an extra hour and helping out there.
No worries. Can I talk to you a little bit for like a minute after class?
Sure. Yeah, we're gonna have to like let everyone leave. Yeah.
I know the procedure.
And some of them might not. Yeah.
Sorry, could I ask a quick question?
Sure.
So for example, on numeracy 3, numeracy 4, question 3A,
okay.
I have my answer, but I got it through like using trial and error and using the equation to see.
Okay, so your answer at the end can't be because you actually plugged in numbers for n.
Right.
So you can use the trial and error to kind of get an idea, right? Is it 0? Is it less than 0? Is it greater than 0? But at the end of the day, your argument has to hold for all n, right? So you have to create some sort of argument that says, regardless of what number I actually chose, this is why it's positive or negative or 0.
Okay, so I would have to use technical terms then, right?
It depends what you mean by technical. Like I am, not necessarily, but you do have to explain why it works in general, not for particular values of n.
Oh, okay, I see. Thank you.
No problem. Okay, right. And see, we've got a couple people hanging out who don't want to leave, Aziz. And I can't kick them out, because if I kick them out, they can never get back in.
Actually, yeah. Wait, I think if I press the remove button, does that just?
Yeah, it bans them forever.
That's great fun.
Yeah, so don't do that one.
I mean, I don't know these.
Well, here's what we'll do. We'll meet in Slack.
Can you do that?
Yeah, I can turn. We won't have video, but I assume you don't need video.
No, I don't care about video.
Right. Okay. So I'll see you in Slack.
All right.
I'll call you.
Sounds good.
Okay.